Hello students, continuing with number system, let us see how we can locate irrational numbers on a number line. But before we actually go about plotting irrational numbers on a number line, let's see what funda are we going to use. Have you ever heard before of something called as Pythagoras Theorem? I'm sure you must have done this in your 8th grade, but just in case you do not remember because you're just back from your vacations, let us quickly revise it, okay? So if I have a right angle triangle, A, B, C, okay, and B is the right angle over here. Given this length and this length, we need to find this length. First of all, the side opposite, the side that is opposite the right angle is known as the hypotenuse. Right? And according to Pythagoras theorem, you have hypotenuse square is equal to the sum of square of both these sides, right, is equal to AB square plus BC square. Okay, so let's take an example. Suppose this side is 3 and this side is 4. So hypotenuse square, I need to find this side, right? This is going to be equal to 3 square, AB is 4, so 4 square plus 3 square, right? So 4 square we know is 16 and 3 square is 9, right? So 16 plus 9 gives me 25. But this is a square term here, right? Hypotenuse square. So I will take square roots on both the sides and find my answer. Taking square root on both sides, what do we get? Hypotenuse is equal to 5 units, right? Now hypotenuse is nothing but AC. So AC is 5 units. Right? So we saw how to find the side opposite the right angle using the Pythagoras theorem, okay, which is nothing but hypotenuse square is equal to the sum of square of both the other sides, okay. So we are going to use the same strategy to find to plot irrational numbers on the number line. Let's see how we do it. For this, I'm going to refer to the solved example on page 7. Okay. So root 2 is an irrational number that we need to plot on the number line or locate it on the number line. So for that I need to first draw my number line. What I'm going to do is go ahead and draw that first, okay. I'll take my center as O, okay, and cut equidistant points from point O for the different numbers. So I have taken equidistant points from O, okay. So this distance is 1 unit, this distance is 1 unit, so this will be 2. I keep adding 1, so 3, 4. Okay. Similarly, on the left hand side, I will have -1, -2, -3 and so on. I'll name my number line as x dash, O and x, right? So let us see how we are going to use the Pythagoras theorem to locate root 2 on your number line. Suppose I have a right angle triangle ABC, where B is my right angle, AB is length 1 and BC is length 1 unit. Okay, both of these are 1 unit. So AC will be what? Under root of AB square plus BC square, right? So this is nothing but under root of 1 square plus 1 square, which is equal to under root of 1 plus 1, which is under root of 2. So we are going to follow the same methodology to locate root 2 on our number line. So let's say I take this length 0 to 1. Okay, so this is 1 unit. You can draw a number line using 1 centimeter each for these each unit. Okay, I'll mark this point as A. Okay, now I'm going to take my protractor, place it on point A. The center of my protractor, see this line should coincide with point A. Okay, and I'll mark a point at 90 degrees. Okay. Now what I do is I take this point that I marked here as 90 degrees, okay, and I join it with point A. So what does this line become? This line becomes perpendicular to point A, right? Now this length is 1 unit, which is 1 centimeter in your books, okay, 1. Now I am going to take length OA, which is 1 unit, okay. I am going to place my compass at point A and cut that equal length, which is 1 unit, on this perpendicular line, right. So once, just please wait. So you notice that this point B that I cut as an arc on this perpendicular line is also 1 unit. A to B is 1 unit, right? And I will join OB. So we notice that AB here is 1 and BC here is 1, therefore AC was root 2. Take a look. So this was root 2. Similarly, we have now the triangle has just reversed, right? But the dimensions are the same. So this is 1 unit, this is 1 unit. Therefore, OB here becomes root 2. Correct? Now with O as my center and B as my radius, OB as my radius, see, I am going to draw an arc on the number line. Correct? So this point here is root 2. Why root 2? Because OB here is the radius. I have taken equal length from O and B, and I have cut the number line, drawn an arc. So even this length here, O to C, let me call this point C. So OC also becomes the radius, which is root 2. We know that root 2 is approximately equal to 1.414, right? So 1.414 is approximately, see, this is an approximate value. So obviously it lies between 1 and 2. So if you notice, this is 1 and this is 2 on my number line, and root 2 is lying somewhere in between, right? So with this we have plotted root 2 on our number line. Let's go ahead and solve the next example, which is plotting root 3 on your number line. This is the same solved example on page 7. I already have root 2 drawn over here. What I am going to do is just extend this line a little bit, that is OB. Okay, and then I am going to place my compass on this line OB with my center, this line 90 degree, the center of your protractor should coincide with point B. and I will mark 90 degrees out here. So I have marked 90 degrees out here. Now what I am going to do is, with this point and point B, I am going to draw a line. Right? So this line is perpendicular to OB, to line OB, right? Now this is root 2. We need to locate root 3 on the number line. So how do we get root 3? Root 3 is nothing but under root of root 2 plus 1, right? Which is nothing but under root of root 2 square plus 1 square, right? Which means I need to have a triangle ABC such that one side is root 2 and the other side is 1. Now you see we already have root 2, which is OB. So I need 1 centimeter on this line, right? From B and on this perpendicular line. So I am again going to take 1 unit. We measured OA as 1 unit, right? So with B as my center and this perpendicular line, I am going to cut 1 unit, right? So this length, let's say D, BD is 1 unit. Now if you take your ruler and draw this triangle OBD, that is I am joining points O and D, right? I have joined points O and D. So this was root 2 over here. I am just writing it so that it looks more clear to you. So this length O to D is root 3. How root 3? Because this is root 2, this is 1, this is the right angle triangle and this is the hypotenuse. So according to Pythagoras theorem, we have root 2 square plus 1 square, which is root of 2 plus 1, which is root 3. So this length becomes root 3. Now with O as the center and D as a point over here, so I take OD as my radius, okay, and I cut an arc on the number line. So obviously OD was my radius, so this arc length that we just cut, let me name it as E. So OE is also the radius. Now the length of my radius was root 3, therefore this point here is root 3, right? Now this point is also lying between 1 and 2, and we know that root of 3 is approximately equal to 1.732. So you see that this point is also lying between 1 and 2, and the actual value or the approximate value of root 3 lies between 1 and 2, that is 1.732. So with this we have learned how to plot or locate irrational numbers on the number line. We will take a look at the exercise in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.